Here is another problem, predicting products. What is a product from when we put that under heat? And again, we see this is the same type of problem with allylic. That portion is the allylic, so your double bond is your vinylic position. Next is allylic. So allylic, and that's vinylic ether. So that would be a Claisen rearrangement. But we need to redraw the structure so that we have that in a cyclic form. So what I'm going to do is I'm going to keep the one part of the molecule the same while rotating the other. So here I have the oxygen. I just copy that the same. And I'm going to do that. That's one more carbon. And then I have a double bond and two metal groups. That's the same molecule, only that I have rotated that bond. Okay, next, once we have identified that, and I'm missing a carbon. I'm not drawing that correctly because that is the allylic portion. And so I need one more carbon and that double bond. But we notice immediately because I had it there. It is the allylic portion. So what's the bond that breaks that bond? Oxygen in that allylic carbon. So it's this one. And I'm going to assign numbers again. So this is 1, and that's 1, 2, 3, and 1, 2, and 3. So now you're going to make a bond between 3 and 3. That's your sigmatropic rearrangement. So now that bond breaks, and you're going to be forming double bond here. And now you're going to make a new bond here and pi electrons over here. Now let's draw the molecule that results from that. Here I have, let's put a circle here, that bond and that, because that is the new sigma bond that I'm making, and here I had two metal groups. Just put these circles to help us identify that. And I had a double bond here. So that is my final molecule, of course. Now we're going to draw it unfolded. So this is just to represent the cyclic structure. And all we need to do now is draw the molecule straight. So we can say, let's start with that's an aldehyde. And now here I have this carbon, which will have a metal and an ethyl. And that's one of these two carbons. This is the other. I have two. And now that's one way of drawing the same molecule, right? And so again, the strategy-wise is the same. So let's do one more problem of the same type. And that could be, again, Claisen or cope. When it's cope, it's just carbons. But when we have allylic vinylic ether, is Claisen. And so now let's draw another molecule. And here you have this O and double bond metal, ethyl, and here I have this, and a double bond here, and a wedge. So again, let's identify what is that. Here I have my oxygen. I have one more carbon away from the double bond, so that is my allylic portion, and that is my vinylic portion. I know that I'm going to be breaking this bond, and so I have the rearrangement. This is 1, 2, and 3, and this is 1, 2, and 3, but I'm going to redraw it so that I have a cyclic transition state. So I'm going to rotate that over to the bottom. That I'm keeping the same, right? And then I'm just going to start folding this. I have one more carbon here, and I have this. And here I had metal and ethyl. All right, so next step would be identifying that we know that's my allylic portion. That's the bond that is going to be breaking. And now when we're breaking that bond, I'm gonna be making this and that. So my final product will have, as we always have in the Claisen rearrangement, a carbon-oxygen double bond. So I'm gonna have this, and these are the two carbons that are gonna be linked together, these, and then now I'm gonna have an ethyl metal and double bond in the oxygen here. And I have this wedge. So that's how would you get your product. Again, the strategy is identical. So keep in mind, this is just practicing, and when you do cope, it's the same, but you don't have the oxygen. So this one's with allylic vinylic ether is the Claisen rearrangement. And I'm gonna do another problem in which we have only carbons with carbons, no oxygen, is the COP, and that's also a 3-3 Sigmatropic rearrangement.